Good afternoon, class. This is Mr. Sadler coming to you live from the internet. I'm probably sitting here at the back of the class making sure all is going well right now. Today is November the 7th, 2014. I'm coming to you live from the internet today. Please play along with the video. If I call on you, please volunteer to answer. If I'm going too quickly, please let the supply teacher, that's Ms. Skiba and Mr. Van Straten, hit pause when necessary. And please play along today and have some fun. Our warm-up today is going to be as follows. Factor, I guess solve for x is the real word. That's going to be 6x squared minus 19x plus 15 equals 0. Okay, so if the supply teacher can hit pause on the video, and I'll give the class about 3 minutes to solve this. You can do your attendance right now, and then we'll go. All right, great, we're back. I'm going to start at the front today. David, can you tell me, please, the M and the A for this question? Okay, good. So we're going to multiply to get 90, and we're going to add to get negative 19. All right, excellent. All right, let's pick on Amy next. Amy, what are the two numbers that multiply to 90 and add to negative 19, please? They are? Great, negative 9 and negative 10. Excellent. Okay, excellent. Kirsten, can you give me the next step? Perfect. Oh, you guys are so smart. Okay, negative 9x, negative 10x plus 15 equals 0. All right, great. Can I get Madison T to tell me what's common, please, between 6x squared and negative 9x? Okay, good. 3x inside the brackets is 2x minus 3. Perfect. Wonderful. Can I get next is, I'm trying to think of my class. Brooke, you're up next. Brooke, what's common, please, between negative 10x and 15? Okay, good. Please note she said negative 5 instead of 5. Why would, if I were to do this, why would that be wrong? Well, the problem is you'd have negative 2x plus 3 inside the brackets, and remember when we do these questions, you need the brackets to line up to be the same thing, and in that case they wouldn't be. So all I'm going to do is I'm going to change that to be a negative 5 and a 2x minus 3 equals 0. Okay, excellent. You're doing a really good job so far. All right, Julia, what's the next step, please? Oh, great. 2x minus 3, 3x minus 5 equals 0. Wonderful. You guys are so smart. I love it. All right, Ms. Eckert, what's the next step after this going to be to solve for x? Oh, wait, I think I heard Logan in the back say quadratic formula. Logan, never use quadratic formula when you can help it. Okay, if you can. So I'm going to do 2x minus 3 equals 0, or 3x minus 5 equals 0. Here we have 2x equals 3, 3x equals 5, x equals 3 over 2, and x equals 5 over 3. Okay? So hopefully that was not that painful of a warm-up. Today, our lesson today is going to be a little bit different, a little bit of algebra we're going to do today. We're going to take a little small break from triangles. This will be on your test coming up in the future, but I decided to take a little break from triangles because the stuff we're getting into in trig is pretty heavy, so I'm going to wait until I'm there before I get into the heavy stuff. Today's lesson is going to be called Solving Inequalities. All right, so this is going to be related a little bit to domain and range that we've done before in the course. We're going to say here, when you write a symbol between two or more expressions, it is called an inequality. Some inequality, let's try it again now. Symbols, oh my goodness, to be used in this class are. I'll give you guys a second to, and maybe the supply teacher can hit pause here for a sec, because I know I went too quickly there. Okay, some of the ones we've used, we've already seen with domain and range. The first one I'm going to use is going to be this one right here. All right. Okay, who are we up to? I think we're up to Gabriella. Gabriella, what's that symbol there? Great, less than or equal to. Okay, good.
Are you gonna be there?
Just wait. Okay, now, Brooke, one sec here. Brooke is actually talking to me as I'm recording this video. How am I going to do this? All right, so a big thank you to Brooke and Madison Ames for interrupting the end of that last video. Apparently they've told me that no one is actually going to be in class today, so I'm actually wasting my time doing this. Nonetheless, I am going to complete this for you guys that are there today. So the first one was less than or equal to, the next one's going to be greater than or equal to. Then the next one's going to be strictly less than. The next one's going to be, whoops. The next one, the last one's going to be greater than. And we should know this a little bit from domain and range already, so we've used this a lot in the course already. What we're going to do in this case is we're actually solving equations. So we're going to say some examples of this are 3x minus 2 is less than 3, or 5x is, whoops, is greater than or equal to 10. Okay, so in this case what we're doing is you're not just solving an individual equation, you're solving a whole range of solutions. Okay, so if you're saying 3x minus 2 is less than 3, you're not just going to pick one number that will work like as an equal sign. There'll be a whole range of numbers like this. So my example is going to be here briefly. We'll just say example. If we say 4x is less than 4, actually maybe we'll leave this for right now. Don't erase that. I'll edit that out, which I won't, but I'm telling myself I will. Okay, so we're going to say, we'll just do a new title here, which will be called Solving a Linear Inequality. If I could spell. When both sides of an inequality are multiplied or divided by a negative, the inequality must be flipped. Other than this, the algebra is the same as when isolating a variable. Okay, so here's example 1. Okay, we're going to say here x plus 3 is less than 4. So let's just, this looks a little bit frightening. Okay, you're saying I don't quite know how to do this. It looks a little scary. What we're going to do is, just like regular algebra from grade 7, 8, 9, and 10, and even a little bit in 11, you want to get x by itself. So let's pretend that was just x plus 3 equals 4. What do you need to get rid of from the left-hand side? Well, the obvious answer is the plus 3. So how do you get rid of a plus 3? I like calling on people even if you're not there, so I'm going to continue to do it even if you're not there. So Amanda, if I want to get rid of a plus 3 on the left, what do you have to do? Good, it's going to be minus 3. So I'm just going to write here subtract 3 from each side. So that's going to turn to x plus 3 minus 3 is less than 4 minus 3. 3 minus 3 is nothing, and 4 minus 3 is 1. So that's going to be your solution. I wish I could box that. Maybe I can't. I'm sure there is a way to outline. I don't know how. Okay, so that's an easy one. We'll pick up the intensity a little bit right here. Example 2 says 3 bracket x plus 2 is less than 5x plus 2. All right, this is a little more frightening, but just if you're a little afraid of this, just pretend that that's an equal sign in the middle instead of a less than sign. So if that was just 3 bracket x plus 2 is equal to 5x plus 2, what would the first step to be for this, to solve for x? All right, Tiana, what's the first step going to be? Okay, great, you're going to get rid of the brackets. So it's going to turn to 3x plus 6 is less than 5x plus 2. Then what we're going to do is, and I'll maybe do my comments on the right here, I'm going to say you want to x's on the left, numbers on the right. Oops. Okay. So what I'm going to do is I'm going to subtract, whoops, 5x from both sides. That turns to 3x minus 5x plus 6 is less than 5x minus 5x plus 2. It turns to negative 2x plus 6 is less than 2. I'm going to give a second to let the power of this question sink in. And then we're going to keep going here. All right, so I want to get rid of the 6 next. How to get rid of the 6? Plus 6. All right, great. I'm going to subtract 6 from both sides. That's going to change to negative 2x plus 6 minus 6 is less than 2 minus 6. Someone is going to ask me in this class, let's call him Ben, even though he's not here today, but he will be watching this on the internet tonight, I am sure. He'll say, Mr. Sadler, can I go right from here to here in one step? Yes, you can. You can start here and then go to here, and then go to here, and then go to here, and that's okay. Right? All right, here's the trick. So if you're fading out of today's class, this is the part to fade in. We are going to, we're going to divide both sides by negative 2 and flip the inequality. So that's going to be x now is going to be greater than 2. Okay, so whenever you multiply or divide the inequality, the multiply or divide both sides by a negative, it's going to flip the inequality. If you don't believe me, and people always say, I don't get it, why does that happen, Mr. Sadler? This is the reason why. Let's say you have negative 2x is less than negative 4, and I just solve it the other way. Let's say I call that 4 is less than 2. Where I got 2x, reason I got that was the negative 4 started on the right, flipped over to the left, changed from negative 4 to 4. The negative 2x on the left switched to the right and changed to negative 2x. And then you're going to say 2 is less than x. Well, 2 is less than x means the same thing as x is greater than 2. So they mean the same thing. All right. All right, let's try a few more examples here. Example 3. We're going to say 15 is less than negative 3x plus 1 is less than 21. Okay, now this one looks frightening again because there's 2 inequality signs. The rule is what you do to isolate x in the middle, you have to do to each side of the inequality. Okay, so in this case, what that means is what you do to the middle, you have to do to both sides. So the first step is going to be, step 1 is going to be multiply, expand the bracket in the middle. Oops. Okay, so what that's going to change to is what that's going to change to is 15 is less than negative 3x minus 3 is less than 21. Step 2, you want to have just have a plain x in the middle, so that I'm going to get rid of the negative 3. So I'm going to add 3 to each, to all 3 sides, to all sides. So what I'm going to do is call that 15 plus 3 is less than negative 3x minus 3 plus 3 is less than 21 plus 3, which is 18 is less than negative 3x is less than 24. And step 3 is going to be divide all terms by negative 3, and flip the inequality. So that's going to be negative 6 is greater than x is greater than 8, so negative 8. And again, if you can't figure it out, you're saying, well, does that make sense? Well, in this case, 24 was in fact bigger than 18. In this case, negative 6 is bigger than negative 8. So let the numbers actually be your guide on these if you need to. All right, we're going to do the last set of examples here are going to be for quadratics, and then we're going to call it a day here, okay? So example 4, and thank you for your patience, by the way. If I've been going too quickly, please encourage whoever is looking after you right now to hit pause a lot, okay, between the examples or whatever. What you're going to get after this example is you're going to get a worksheet to do for your homework for the day. This isn't in the textbook, so this is going to be, you'll need to be able to do these and make sure you're feeling good about this. If you're someone who skipped for the football game, shame on you. Yeah, that's all I'm going to say about that. You should be watching this on the weekend on YouTube anyway then. You do not have the homework sheet for you, but if you email me, I can email you back the homework sheet. Okay, so the last question here today is going to be solve. 5x squared plus 9x minus 2 is greater than 0. All right, Andrew is definitely not here because he was actually in the football game, but this is the type of question I would give to Andrew, and he would be afraid. That looks like a quadratic equals 0. How do you solve a quadratic that equals 0? How would you do it? Very good. Step 1 is going to be factoring here. Okay, so we're going to do the m and the a. We're going to multiply to get negative 10, and we're going to add to get 9. Those numbers should be, hopefully, 10 and negative 1. Then what I'm going to do is I'm just going to rewrite it as 5x squared plus 10x negative 2 is greater than 0. Take out a common factor of 5x, and then take out a common factor of negative 1. And you have 5x minus 1, x plus 2 is greater than 0. Okay, so things are looking sort of good, but I don't really see what progress we've made here. Well, the progress that we've made here is that we're going to get our roots here in a sec, okay? So my roots are going to be x equals 1/5 and x equals negative 2. Now, if somebody in the class doesn't understand what happened here for the roots, please someone explain. All we did here is just found the zeros or the roots. What I'm going to do right now is do, well, okay, I'm going to slow down here. What you're looking for, I'll type what I'm thinking here. That might clarify things. And why am I? What you're looking for, oh goodness. What you are looking for is when is the y value of the equation greater than 0. So what I'm going to do is I'm going to graph to find out. You can also use a table of values, and in grade 11 you definitely will be using a table of values, but I'm going to do a very, very rough graph. It's going to be so rough, I'm going to use paint to do this. Okay, you'll be doing this in your notebook though as neatly as you can. Okay, and what I'm going to do is I should probably show the equation. Oh goodness. That's right, folks. What's going to happen here is I'm just going to draw a graph that has roots at 1/5 and negative 2. So this is a very, very rough sketch. It's a very, very big sketch. Let's do a little finer line. Okay, so I'm going to draw two rough points here. This is very rough here. Let's do it in red. Okay, this is going to be my 1, 0. And this is going to be my other 0 over, oops, try again here. Sorry, all discombobulated here after Brooke and Madison interrupted my lesson there before. Okay, so those are going to be my 2 zeros right there. If you want to fill them in a little bit bigger, I probably could do so. Then what I'm going to do is I'm just going to connect them in a parabola. Now, we got to figure out if this graph's going to open upwards or downwards. Since it's a 5x squared, the graph's going to look something like this. Oh goodness, sorry guys. Okay, that's a weak looking graph. Let's try again. That's another weak looking graph. There we go. Okay, so there's my beautiful parabola. Oh my goodness. This is so much easier to do on the smartboard. Okay, so there's my lovely parabola. Now what we need to say is, when is this graph? And hopefully Mr. Van Straten, if he's in here right now, can help us out a little bit on this. What I'm going to do is I'm sort of going to think of this like the asymptotes when we did the reciprocal graphs. Okay, there's going to be 3 sections of this graph. The graph on the left here is going to be x, whoops, I said, the graph on the left here, I'll use black here, is going to be x is less than negative 2. The graph in the middle here is going to be negative 2 is less than x is less than 1/5. And on the right here is going to be x is greater than 1/5. And again, this should look familiar to you from our interval charts on the reciprocal graphs. So what we have to think is here is when are the y values positive? Well, if you take a look here, in this interval, x is less than negative 2, the y values are positive. In this interval, from negative 2 to 1/5, they're going to be negative. In this interval, for x is greater than 1/5, they're going to be positive. So we're going to say, when is the graph positive? We're going to say when x is less than negative 2 and x is greater than 1/5. Okay, hopefully that's somewhat clear what happened there. Mr. Van Straten, maybe you'll want to pitch in here if he can at any time here. If not, we can talk. I'll do a warm-up like this on Monday to clarify. What I'm going to do now is I'm going to stop the video and give you guys the rest of the period to work. I will give you, some homework sheets to work on here right now, because as I mentioned, it's not in the textbook. If you are not in class today and you're watching this online, once again, shame on you. And send me an email and I can forward you over the paper that you need. Okay, thank you very much. See you later.